to solve another Leetcode problem, 1262. Greatest sum divisible by 3. So we are getting an integer array nums. We're going to return the maximum possible sum of elements of the array such that it is divisible by 3. So we want to check the sum of the element as much as possible, or as big as possible. So for example, 3 plus 6 plus 5 plus 1. So the sum of them are gonna be 15, but it's not the biggest. Maybe we're gonna choose 1, 6, 3, 6, 1, and 8. So the sum of them is gonna be 18, and 18 gonna be the maximum. So finally, we're gonna return 18. This problem is not so easy by doing it forwardly. We might need to solve it reversely, because if we try to solve it forwardly, maybe for a number like 3 and 6, it is divisible by 3, because 3 modulo 3, it is 0, 6 modulo 3, it is 0, it is okay. So for such numbers, if it is divisible by 3, we can just take it. So it means 3 plus 6 is going to be 9. Yeah, but except that there are going to be some other numbers. It's going to be divisible by the result, I mean the remainder. For this number divisible by 3, the remainder may be 1 or maybe 2. So yeah, so how many numbers the remainder is going to be 1? So we have a number of 1. Yeah, but how many numbers the remainder is going to be 2? So for 5, because 5 modulo 3 is going to be 2, and 8 modulo 3 it's going to be 2. Yeah, now if what left behind is for the remainder 1 to 2, it can be a long array for this remainder 1 or remainder 2. It can also be a very long array. I mean, this array can be very long. So if we do it forwardly, maybe it's going to be difficult. We have to check if there are 3 numbers or 3 numbers we can take it out. But what left behind is, so for example, if we left behind with 3 ones, so for the remainder 2, what we left behind, maybe we just left behind 2. Yeah. So how can we solve such kind of issues? Maybe this 1 plus 1 plus 1, it is also okay. Yeah. Here I just prepare a number with 1, 1, 1, but you can put some other numbers, maybe 4 or 7, it is also okay. So for such cases, will you just remove those 3 ones, because definitely it is okay. Or you will just choose one number from this array 2, another number from array 1. So if you choose one number from array 1, it is 1. Another number from array 2, it is 2. So 1 plus 2, so the result is going to be 2. So for another case, maybe you just remove those 3 ones. So 1 plus 1 plus 1, it is also 3. So 1 plus 2 is 3. This is also equal to 3. Yeah, so it means we don't know how to do it if we do it forwardly. Or maybe this number is a 4. So if this number is a 4, so how can we solve it? Maybe we're going to choose a number of 4 here. Here we're going to choose a number of 2. Yeah, so 2 plus 4 is going to be 6. 6 is bigger. Or maybe you just want to choose this 4, this 1, and this 1. Or maybe this 1 is not 1. Maybe this is also 4. Yeah, so it means we're going to choose 4 plus 4 plus 1, because it is 9. 9 is bigger, because 2 plus 4 is only 6. Yeah. So for such cases, there are too many different cases, so this is not so easy. Try to solve it forwardly. So instead of trying to solve it forwardly, so we're going to try to solve this problem reversely. So this means we're going to calculate the sum of the nums directly. So we're going to prepare an S. It's going to be the sum of nums. Yeah, the sum of nums. Yeah, I didn't write it so clear. So we're going to prepare S. So it's going to be the sum of the nums. Yeah, basically it is the sum of nums. So for example, the sum of nums, maybe for this example, it may be 23. Yeah. Now we want to use the sum of the nums modulo 3. So for this 23 modulo 3, what's going to be the result? So the result is going to be 2, or the result is going to be 1, or the result is going to be 0. So if the sum of the nums modulo 3, the result is 0, definitely we can return the sum of the nums, this S, immediately, because we don't need to check anymore, because the remainder is 0. But what if the remainder is 1 or the remainder is 2? So we just need to prepare two arrays. Let me prepare A1 and A2. So for A1, we just put the numbers which the remainder is 1 inside the A1, and for A2 we just put the numbers which the remainder is 2. Yeah, let's just try some examples. So maybe for A1 I'm gonna try maybe 1 1 4. Yeah, I think it is okay. So for A2, maybe I would to prepare also 3 numbers, so the remainder gonna be 2, maybe 2, 5, and 8. Yeah. So I have A1, the remainder gonna be 1, and A2, the remainder gonna be 2. Yeah, this means, but what is the remainder for this sum s modular 3? So if the modular 3 gonna be 1, if the s modular 3, if s modular 3 equal to 1, it means the sum of the nums modular 3 equal to 1. So what I gonna do? I just need to check A1 and A2. Because the modular, the result is 1, I just need to take one number from A1 or two numbers from A2. Yeah, because all the numbers inside A1, the modular, the remainder gonna be 1 after modular 3, because for modular 3 it is also 1. So I want to choose the smallest number, so it's gonna be this one. Yeah, or I can choose two numbers from A2 if the length of A2 is more than 1. Yeah, or maybe I'm gonna choose 2 and 5, because 2 plus 5 it is 7, 7 modular 3 it is also 1. Yeah, so I have two decisions. I can choose one number from A1, or I can choose two numbers from A2. Yeah, because the remainder for A2 after modular 3 is going to be 2. So 2 plus 2 modular 3 is going to be 1. Yeah. So similarly, if s modular 3 equals to 2, I just do it reversely. It's the same. Yeah. So for A1, I need to choose two numbers. And for A2, I just need to choose one number. That is enough. But I want to choose the smallest number. And here two numbers, also the smallest two numbers. Yeah, I think that's for it. But what if A1 is empty or A2 is empty? Because it happens. If A1 is empty, we don't need to choose numbers because there's no numbers for us to choose. Or A2 is empty or the length of A2 is 1. I don't need to choose numbers because at least I need to choose two numbers. Yeah. So this means for simplicity or for reduce the writing so many lines of code, if the s modular 3 equal to 1, it is okay. It is still A1 and A2. If the s modular 3 equal to 2, I need to change the places of A1 and A2. After shifting the places, I can use the same formula to calculate it. Yeah, because no matter s modular 3 equals to 1 or equals to 2, so for A1, I just need to take one number, and for A2, I just need to take two numbers. Yeah. Because if s modular 3 equal to 2, I will shift A1 and A2. After shifting, everything should be okay. Now, let me calculate it. So basically, this is a mathematical problem, and it also concerned with greedy. And for the greedy, idea is that because we're going to use the sorting, and let me think about if we did use some other ideas. I think it is a mathematical problem, and we're going to use the sorting, and we're going to use the greedy idea. Yeah, basically I think it's all about that. So for this s, it's going to be the sum of the nums. Yeah. Now we need to check if modular 3 equal to 0. Definitely we can return the s immediately. Otherwise, we're going to prepare two arrays. So for A1, the remainder is going to be 1 for all those numbers. So we're going to prepare n. So for a nums, if n modular 3 equal to 1. Similarly, we're going to prepare another array. So the remainder is going to be 2. So we're going to prepare A2. So the remainder is going to be 2. Now, what we need to do is that we want to check the remainder for s modular 3 if it is equal to 2. So we're going to shift the places of A1 and A2. So it's going to be A2 and A1. This is just for simplicity. We don't need to have so many cases to check, because in this case, if s modulo 3 equal to 1, we're going to keep the same position. So it means inside A1, the remainder is going to always be 1. But what if s modulo 3 equal to 2? So for A1, actually it equal to A2. It means inside A1, the remainder is going to be 2. Yeah. So in this way, we don't need to check so many cases. We only need to check this line, and after that, we just need to check the minimum. Yeah. So we're going to prepare a result. So the result is going to be the sum s minus A1. So for A1, no matter the remainder is 1 or 2, for A1, we always want to choose one number instead of two numbers because we have this kind of line. Yeah, if the remainder is 1, definitely we're going to choose one number. But what if for A1 the remainder is 2? It is still okay because currently this s modulo 3 equal to 2. It is still okay. So this means we're going to choose one number. So if it exists, otherwise we will not choose it. So it's going to be s minus 0. Yeah. So this is going to be the first condition. So the second condition is that we're going to check A2. So if the length of A2 is more than 1, definitely there are at least two numbers inside the array A2. So we're going to check the maximum of the possible result. So it's going to be the maximum with the result. Yeah, because the final result is going to always be the maximum possible value. So we need to choose the maximum of this result minus A2 0 and A2 1. Yeah. So for here, since this is a greedy idea, I need to sort it. So let me just use sorted for this array. And here, similarly, I need to sort it. Yeah, because no matter which way I choose the first value, it's going to always be the smallest value. If I choose two numbers, it's going to always be the smallest numbers with A2 0 and A2 1 because it is sorted in increasing order. Finally, I just need to return the result. Yeah, as you can see, the coding is quite clean, but if you don't use this kind of idea to check, basically you need to write a lot of lines of code, and it's really easy to make mistakes. So in this condition, because we shift A1 and A2, if the modular to 3 equals to a different value. If it is 2, we're going to just shift it. If it is 1, we don't need it because there are only two cases, so we can use this kind of code to save the remaining lines of code, because for here we just need to use this s minus the first value inside A1, no matter the remainder is 1 or 2, because we shift the array A1 and A2. And for the second one, we have to check if the length is more than 1, we have to check the final result. It's going to be the maximum of the result with result minus A2 0 and A2 1. Let's just use an example maybe. I think this is a good example. So this is A1. Inside A1 we have a value which is 7. So here so here for A1 we have a value of 7, and inside array A2 we have a value like 2, 2, and 2. Yeah. So for A1, a modulo 3 equal to 1, 7 modulo 3 equal to 1. For A2, 2 modulo 3 equal to 2. Now we're going to decide how many values we need to remove. It is always dependent on this s modulo 3. So if this s modulo 3 equals to 2, just imagine we only have those four numbers, 7, 2, 2, 2, so the result is going to be 13. So the 13 modulo 3 is going to be 1. Yeah. So if the result is 1, we don't need to shift A1 and A2. It's going to be the same position. Yeah. So for the first step, we're going to check the result. It's going to be s minus A1 0. So it's going to be the 13 minus 7. So for here, it's going to be a 6 because A1, it has a value. So it's going to be a 6. And what about A2? If A2, the length of A2 is more than 1, we just need to choose two numbers, 2 and 2. So it's going to be 13 minus 4. So it's going to be 9. So the final result is going to be the maximum of 6 and 9. As you can see, it's going to be 9. Yeah, because if we were to choose 9, what's going to happen? We just need to choose 2, 7. So it's going to be 9. We just need to remove those two. Actually, it is these two, the first two numbers. Yeah. So this is the idea why we're going to check it like that. Yeah. Or maybe we can also use another example. Maybe here inside it is 1. Yeah, and this is A1, and inside A2 maybe it is just 2. Let me prepare maybe another 2. Yeah. So in this idea, the sum of them is going to be 1 plus 2 plus 2. It's going to be 5. So the remainder is going to be 2. So if the remainder is going to be 2, we're going to shift A1 and A2. So here, the A1 becomes 2 and 2, but A2 gonna become 1. Yeah. And the first step is that we're going to check S minus A1 0 if there is A1. So 5 minus 2, it's going to be 3. For the result, it's going to be 3. Yeah. And then we're going to check this result going to be 3, and the result going to be minus A2 0 and A2 1. Because the length of A2 is only 1, so we don't need to check that. So the final result going to be just 3. Yeah, we have 3 numbers 2 to 1. Actually, we just need to remove a 2, so it's going to be 3. Yeah. So this is how we check if this kind of algorithm works. Yeah. Now let me just submit it to check if it works. Yeah, it didn't work for some cases. Let me check. So this is 8, 10. It should be, yeah, it should be 15. This is a 9 plus a 6. It should be 15, but I get a 12. Let me just check that. So I got A1 and A2. A1, A2 should equal to A2, A1. So the result gonna be the S minus A1 0 is A1. Otherwise, it's gonna be S minus 0. Yeah, I must make a mistake from someplace. Let me check my summations maybe. Let me check what is wrong. Yeah, definitely I cannot find what is wrong with it. So this is a sorted array, and this is also sorted. A1, A2, A2, A1. Yeah, I think it's exactly the same code, but it is wrong. Yeah, let me make a comment of this place and check what is wrong with it. Let me comment those ones and submit it. Yeah, I believe this code works. Yeah, as you can see, it works, but for my code it didn't work. I just yeah, I think it's exactly the same. So I calculate the sum of them and modulo 3 and A1 and A2. If n modulo 3 equal to 1 and n equal to 2 and s modulo 3 equal to 2, I'm gonna change A1, A2, A2, A1. Yeah, it's exactly the same, but it is wrong. Yeah, I think I made a mistake from here. Yeah, because this is not result minus A1 and A2. This is the S minus A1 and A2, because if I use the result minus A1 and A2, definitely this is going to be smaller and smaller. Yeah, I'm going to always choose the smaller value. Yeah, but actually it is not the result. The result is just a temporary value. Here I calculated it, and then for the final result, I'm going to prepare my current result with the S minus this A1 and A2, because here this S minus A1 0, here should be S minus A2 0 and A2 1. Yeah. This is why. Yeah, now as you can see, it works. And thank you for watching. See you next time.